This is a screencast about Malta's processes work of Greg Meredith with David Snyder, which is I. Who is I? Am I? So, let us begin with a simple four-valent graph, not diagram pretext. So, in this case, we have actually some vertices of valency 2, but all the interesting vertices have valency 4, and removing those vertices we get a not context, which is recognized by the fact that we just get a forest of edges. And then we provide a crossing at each one of these former vertices, which could be either undercrossing from the upper left to the eastward pole here, as I've got it on right now, or it could be an overcrossing from between those 2 points, and opposite points cross. Connect, sorry. So we plug them in various ways. In this case, the way I've plugged them in, they all go the same way, so to speak. They're just rotations of each other. You actually get a knot diagram, which is a planar diagram describing a knot. I'll try to make it more obvious which it is. In this case, a trefoil knot. You can see a trefoil knot sort of sitting there. It's a planar projection. So if we go back and look at the knot context, we could also think of it as a wiring harness. And here are the wires. Here's one of the wires. There's 6 of them. And at the end of each wire, we have splice points. We're going to describe each one of these wires as a process with 2 ports that are able to communicate with the crossing. So a crossing circuit we are going to visualize as following way. This is what we call the crossing boundary. And on the north side we have 2 ports called X0 and X1, and on the south side also 2 ports, Y0 and Y1, and when we look at it this way, we'll label consistently that X0 and Y0 are adjacent along the not crossing boundary. X1 and Y1 are also adjacent along the crossing boundary, and we can have the convention that X1 goes over to Y0 and X0 goes under to Y1. Wire circuit is obviously a little bit simpler. We can just visualize it like this, where we have the wire and then we have port X0 at X and a port at Y. You like the splice point X could be connected with either X0 or X1 or Y0 or Y1, in which case that name would be the same as whichever